Welcome to a special episode of Truck Tech. I'm live at Manifest, and I'm super excited to be talking with the folks from Bot.Auto. Xiaodi, you have quite an amazing story, and I think that folks who aren't as familiar, tell us a little bit about yourself and give us some background on what Bot.Auto is.
Bot.Auto is an autonomous trucking company, of course. We do transportation as a service. We utilize the newest technologies. We wanted to bring this technology to real commercial use as soon as possible.
And that's one of the big conversations is commercialization. You've had experience formerly being at Too Simple as well. You're very familiar with the game.
Yes.
Tell us a little bit about your background and what are you seeing right now in terms of where AI is going? Because one of the common themes of this event is like, oh, we're here now. What are some of your thoughts?
Well, I think my past experience tells me a lot of things, but I think most importantly, it confirms the idea that autonomous driving is really at the cusp of a completion.
Yeah.
And we're about to make it happen this time with all of the, we don't fall in the same pitfall again, and we work hard. I'm pretty confident this time it will work.
So let's talk about the game plan then. You guys are just recently launched. You've got some awesome video right here as well. Tell us a little bit about the story on how not only you're setting it up, this is an example of a successful merge, but give us a preview on how the technology works too.
Right, yeah. So we started the company with the basic assumption that we're not going to raise a lot of money. The market does not allow that. And we have to find a scrappy way to make it work. So that's where we start the Bot.Auto with that mindset. And this comes down to how we organize the team. We have a very small, lean team. The demo that you saw is completed with a team of less than 50 people in total, including the tech and non-tech, everyone included, less than 50 people. And I believe a little bit more than $16 million in total that we spent in 1 year and 3 months.
Holy cow. Because I mean, that's one thing I've heard in conversations with the past between AV 1.0 and AV 2.0 is that in the past you needed thousands of people to process all of this. Now with AV 2.0, there's combinations of generative AI and other means of doing it. Is that one of the things now that you all are starting and building? Are there some advantages you can kind of piggyback off of in this second wave?
Definitely. I think the biggest advantage is forget about what we built before and restart again. I think in that case, we have the minimal amount of technical debt and managerial debt. And the key thing is really like focusing on the new technology because, for example, if we're using transformers right now in this model, like we have one pretty big foundation neural network to subserve all of the functionality that we have. But on the other hand, all the LiDAR data, camera data, we treat them equally and we would just like digest all of the data in one neural network. And also we have adopted a lot of the pre-training techniques that are used prevalently in training the gigantic large language models. We also use similar techniques and similar spirits in here so that we're dramatically reducing the operating cost of annotation and of training the neural network. All of these are actually helping us to build a robust, functional system at a fraction. I think the annotation cost is about 1% of what we have used before.
Oh, wow.
Actually, sorry, 2% of what we have used before.
So talk about annotation. That's where you're looking through the data and you're trying to find out what should I have done or what could I have changed or what have I seen in the past? Is that part of the training, the annotation?
Yes. Right. Good. Annotation is basically teaching you this is a box that is this is a bounding box of a car, that is a truck, that's a pedestrian, and many of that are previously done by very intensive, labor-intensive human effort, like human helping computer to recognize every object on the road. But we started off by taking the video shot, just like let the truck drive and collect the data, but we learn the data by itself without annotation. So as a matter of fact, the first bill we ever pay for the annotation starts in, I think, March of 2024. We started working in the end of July of 2023. So basically, after half a year's working, we started to, okay, so now the simulation data, the self-supervised training data is not enough. Let's have a fraction of annotation data, but that happened very late in the stage.
That seems to be one of the things I'm hearing is you need like a combination. So you're taking the generative portion, you're taking all of this stuff either real time or previously, but then you also need like kind of, I guess like Isaac Asimov's rules, the laws of robotics. So is that something we're looking at in the autonomous space? Is that one of the things you have to also do it? Because one person I spoke to, Wabi, that said it can be like a black box if you just do all Gen AI, because you don't know why it did something. Is that one of the challenges making an AV where you kind of got to figure out, you let it cook, but then also there's a few boundaries like any good relationship.
Very good point. Yes, we did maintain a very strict boundary on the deep learning. We know two things that cannot be done by deep learning, and I'm probably one of the biggest voice advocating against end-to-end learning, because I really don't like that opinion, because that's really like end-to-end learning gives you a black box that you cannot decipher. But we want it to be responsible and we want to be safe. So two things that we believe that cannot be done, where it's going to be a very indirect way to be done by neural network. One, regulations. The neural networks learning regulations by rule, like by data. Learning regulation rules by data is a very inefficient way of handling the traffic regulations. So we don't do that. We hard code it. On the other hand, the physical laws. Learning physical laws by data, as soon as given that we already have Newtonian physics like for hundreds of years, that's also a waste of resources, and we don't want it to do that.
Because you're almost wasting compute if you're having to make it figure it out and do real-time count. So if you have the hard-coded things like traffic laws and distances and
Newtonian physics.
Yeah, so if you just teach it Newtonian physics, you're not going to have to use as much compute on the back end, and it allows it to free up for other processes.
Right. And also with those two boundaries, with the physics and with the regulations, like the traffic rules, we actually form a very safe boundary for where the vehicle can actually go. So basically, in mathematical terms, the solution space of our autonomous driving system is very well bounded. So we know that we are not going to make some crazy moves in the middle of the driving. And what the computer vision and all of these machine learnings are going to help the system is really to help giving suggestions. But all of the results that they're going to pick up is in this safety boundary.
Yeah. And I mean, looking at this as well, I think this is really cool. You're showcasing it. Is that kind of standard, having LiDAR, radar, camera waves? Talk about some of the hardware that y'all are putting in on this. Is that something similar across all the AV space, or the only one I hear of is Tesla that doesn't have LiDAR and other ones, but.
Yeah, the funny thing is that Tesla is not a level 4 autonomous driving company. Tesla is providing always the level 2 results, but they're trying to, appear like a level 4 company, but in fact, they are not a level 4 autonomous driving company. And on the other hand, all of the autonomous driving level 4 companies, I think, are converging to the consensus where LiDAR is needed, camera is needed, and I don't really consider the whether to have LiDAR or non-LiDAR as a religion question. Yeah. It's stupid to talk about religion. We're talking about a product. So if we're thinking about whether to have LiDAR or not, it all comes to one point. Is LiDAR too expensive or not? Yeah. And my answer is no, they're not too expensive. Probably they're already too cheap.
That was one of the things I heard. It's like, oh, it's too expensive, the cost. I was like, but don't you kind of need it if you have 80,000 pounds?
Yes. Thinking about, in terms of the cost, I would like to interpret the cost from a cost per mile perspective. Meaning that, okay, how much money can we make with this very big rig? And considering the unit cost for installing and purchasing this additional hardware, and more importantly, by operating this very complex object. Because the operation cost includes a lot, like the sensor cleaning cost, a debugging cost, and a map maintenance cost, everything, and the teleoperation cost, everything altogether. So all of these costs are actually much bigger if you compare that against the unit cost of the LiDAR. The LiDAR is like several $1,000. Yeah. It could be even less, right? And it could be cheaper next year.
If you're cutting corners or saying, is there like I heard compared to battery packs, there's one supplier that has 80%. With LiDAR, is that something where there's just a lot of optionality you can choose around? Like, is there a specific one for like Bot.Auto, or is that everyone goes with? Or I know it's a kind of random question, but
I think it's really all of the autonomous driving company goes to Hesai. Yeah. And this is like more like a winner-take-all scenario. Hesai got a lot of orders from level 4 autonomous driving companies. Aurora using them. I believe Waabi also uses them. I'm not entirely sure, but I believe so. And we use them, obviously. A lot of people using like one supplier, and the supplier can get cheaper and higher reliability. So it's a positive reinforcement for those who supply the most of the LiDARs in the world.
So let's talk about next steps here. We've got a demonstration here. What are kind of what's your short term and what's your long term for the rest of the year? What are y'all hoping to anything to announce or anything on the horizon we should be paying attention to?
Well, I think I can give you a spoiler. We are heading to the very obvious goal for the next, that is driver out. So definitely this is our goal, but prepare for our formal announcement about that. We are going to set that as our next goal. But only that's an intermediary goal. We don't consider driver out as a completion of the autonomous driving system, but on the other hand, we do consider this as a completion of our redundancy architecture. Yeah. And the testimony of that redundancy architecture completion is a driver out run. And of course, we're going to do more of that in the future. And the next step after the driver out, I think that will be the most important one. That is, we have regular operations where our costs can beat human.
Yeah, because right now, I think that's really fascinating. There recently was a panel as well talking about redundancies in the driver out systems. And so that's what blew my mind. For these vehicles compared to like smaller Teslas, little robo things, what are the cabs called? I don't remember what they're called anymore. The ones in San Francisco, you know.
Cybercab.
Yeah, all they have to do is basically if they crap the bed, they just stop. But when you're we have a semi on an interstate, you need redundancies to make sure that it can pull over and stuff. So that's part of the driver out, right? That's what you guys want to prove is that even if we do lose something, even out of this combination of sensors that happen, we're able to safely navigate and even operate if we're losing like half our stuff.
Right, exactly. But also there's an advantage for operating a truck rather than a passenger car because we don't have passenger in it. Like nobody's gonna complain if we like stop at the roadside and wait for 5 minutes. Nobody's gonna complain about it because you know, we're safely navigating ourselves on the roadside and we're patiently waiting for rescue or to fix our hardware failure, like you know, maybe like a power failure or a sensor failure. It will happen very rarely these days. I mean, thanks to all of the ecosystem growth, we're not really seeing the hardware failures as often as you can imagine. But yes, but we do have to be prepared for that. This is you know, how a responsible driver out run should be prepared for, and we're also be very proud that we're very responsible for all of the so-called single point of failure. We have the mitigation plan.
Yeah, no, that's the best conversation when you're more likely to lose a tire than you are one of the sensors.
Oh yeah, exactly. Yeah. I think losing tire is one thing that we can only, you know, reactively handle because you can lose a tire in any whatever situation on the road, right? Yeah. But for sensor failure, actually, that's a much easier mitigation. We can just have more sensors. You probably don't see the exterior in this video, but if you go to our website, you can see a lot of cameras, a lot of LiDARs. Why? Because every single one LiDAR or camera goes down, no problem. And even for a computer, we have two computers. One goes down, the other can start a backup plan and pull a vehicle gently to the roadside.
Do y'all still use, is that one of the things as well? NVIDIA, one of the big CES things, also announced that Blackstone architecture, AI applications. Is that something when you're wanting to build your autonomous company, is there only a few providers for the compute, or is that something where maybe there's a lot of other options as well? Is that something that people keep in mind when you're looking at what's going to be powering the...
Yeah, practically speaking, I think, yeah, NVIDIA is the only choice that we have.
That's why I can't build my own computer right now. Everyone's buying these chips.
Yes.
Oh my gosh, but... Okay, looking ahead, being at the conference, getting to talk to people, you know, you're very well versed in the space. You understand quite a bit about the AI. Well, is there anything you're seeing or hearing, especially in the autonomous space? Is everyone converging into a similar lane on this path, or is anyone having a specific different flavor towards this ultimate end goal?
I think there are two interesting things. One is expected and the other is not. So the expected convergence is that I think people are more and more talking about cost per mile. Like people don't really view the technology achievement as a mind-blowing thing because people have seen that. Yeah. So more and more people are getting practical about autonomous driving on, okay, what is your cost per mile? Like, I think I'm one of the few, if not the only, that has, if not the first, that has proposed this cost per mile concept in the autonomous driving field. But now people are getting very receptive about that concept. So it's not an alien term to most of the people. So I'm glad this is happening, and this is a expected convergence. The other unexpected convergence is that, as you know, we're taking a very scrappy way of doing autonomous driving. I think even last year, I got an overwhelming amount of challenges. People are saying, okay, Xiaodi, you don't have enough fleet, you don't have enough mileage, you don't have enough compute, you don't have enough resources, whatever resource you put in, like a headcount. But this year, after the wake-up call from DeepSeek, I think more and more people started to realize, oh, you know what? The power of innovation can be that great. Yeah. Thinking about innovative culture and innovative spirit, we are at the innovate or die scenario, that we have to innovate. So I'm pretty proud that the team has went through this path, and quite coincidentally, DeepSeek has told everyone about the power of it. So I think a lot of people like independently told us that, oh, Xiaodi, I thought that you are the DeepSeek of autonomous driving. I say, yes, you're right. I always believed so. And I told you last year, and finally you realize that. I'm happy. Now, so this is more like unexpected like thing that we see more convergence on.
And I really appreciate your time as well. Looking ahead, being the DeepSeek, I really like that just because you see a lot of these first movers that are well capitalized. Now with the technology and the ability, you don't have to have that. You can have, because you're not laden by all the tech debt and all the other silliness. So looking forward, that's going to be an ability to really spring forward and catch up that parity as you guys are developing. Perfect. Well, I really appreciate your time. Folks want to learn about Bot.Auto or get in touch as well. What's the best way to find out?
My email, Xiaodi.Hou@Bot.Auto.
Perfect. Really appreciate your time. That's it for this episode, but we got a lot more of these things recorded, so stay tuned. More coming your way. Welcome to a special edition of Truck Tech. I'm Thomas Watson. I've been at Manifest looking at trucks and tech. So you can imagine I'm super excited to be talking with the folks at Forterra. They have the Auto TT, and they have some really cool stuff to talk about as partnerships as well. So I'm joined by Josh Araujo as a CEO. And Josh, first tell us a little bit about yourself, and then let's see what we're looking at.
Yeah, sure. So you're looking at an Auto TT. It's a Kalmar yard truck integrated with Forterra's AutoDrive autonomy stack, as well as the Electrans auto coupling unit for the glad hands on a Stoughton faceplate. So this is a fully integrated end-to-end solution for fully autonomous yard and port logistics solutions.
And I think this is really cool because it's a partnership of three things. One of the big challenges is how do you hook up airlines? And so the autonomy space has been doing a really good job with navigating the yard, but you all are providing a solution as well to help the final portion of it.
Yeah. So we think any solution is going to have to be end-to-end. You got to provide a end-to-end product that really simulates and enables what a human currently does. So it's got to be a fully baked product, tightly integrated with the base vehicle, tightly integrated with that glad hand solution, and really providing a seamless experience and capability for our customers.
And it's really cool the folks at Kalmar are making the tractors, and then you all are installing the stuff. So it's a three-team effort because you also have the providers who are helping hook it up as well, right?
Yeah, our view is, autonomy has to be tightly integrated with that base vehicle. So it needs to be a seamless solution to the customer of base vehicle, autonomy, any type of payloads or integrations need to be really delivered seamlessly to the customer to make this effective.
And you're also participating at the event. We're dating ourselves here. There's an upcoming panel here, but I think for listeners as well, give us a preview about not only what you're talking about, but kind of what you hope to impart upon some of these folks from all across the industry.
Sure. I think the panel's really about autonomous trucking and how that's really making really gaining ground over the last couple of years, and really this year is the year of deployment. Although we're doing yard trucks, we think it's a very similar adjacent application for autonomy. So we're going to be talking, particularly for us, is how we leverage our dual use. So this is providing the same AutoDrive autonomy software and hardware for military applications, and how that really benefits both our industrial customers as well as our military customers from really having this dual use capability.
And I like that aspect because, expanding in commercial, heavily involved in military with defense. Tell us a little bit about some of the, from what I've understand, one of the benefits is that if you have some military vehicles that are operating autonomously, you can kind of double dip. And then all that learning from that, very rough terrain and rough environments can go into the more calmer, chaotic ones of a yard.
Yes, I mean, really what we're passionate about many things. One of the things we're very passionate about at the company is taking soldiers and Marines out of harm's way. And one of the best ways to do that is to deliver a commercial solution. We've seen it time and again in many defense technology applications is interjecting technologies that have commercial applications. Really, one, increases the capability for the warfighter, and two, it allows the companies to deliver it at a much lower price point. So we look at it as we can take these learnings, take the economies of scale, take all the things that we're getting out of the yard applications and deliver that to the warfighter. Conversely, we can take all the learnings and miles and rugged environments operating in snow, sleet, dust, hail, in unstructured environments, and use that to refine our capabilities back to the warfighter. So we see it as a very symbiotic, really that we find the yard case to be a very applicable dual use scenario.
Well, I mean, it kind of opens other doors as well. The U.S. military has a very extensive supply chain, and one of the things I've noticed is that they take a lot from the civilian supply chain in terms of best practices. So does that also open up, I'm assuming, more opportunities for, you've got, defense, keeping soldiers, Marines, folks out of harm's way. You've got the commercial side. Is there kind of like a middle application where maybe I'm on a base somewhere and I need to have some autonomous vehicle deliveries, or I'm running some stuff in between the lines? It opens up more doors.
Yeah, a large part of the military application, or really military use cases for vehicles, is logistics. Water, ammunition, supplies. That's the vast majority of the vehicles in the military. That kind of tooth to tail ratio of actually weapon systems, soldiers on the front lines. It's a pretty big margin of support logistics. And so a lot of the applications we're doing with the military are logistics applications. So we look at the commercial applications of that technology, they're very similar parallels. And all the things that you need in a commercial logistics yard are exactly the same things you need in a military environment. I think the only difference is we paint the box white here and maybe tan or green for the military.
Well, it was always a Marine, not a former Marine. Correction on that, sorry guys. You can tell I have Army buddies, but was that one of the big things? Bringing that military experience, was any kind of surprising things coming into this commercial sector that you feel maybe they're underserved, or it's like, hey, we used to do it this way and can definitely do better? Tell us a little bit about some of your backstory and then how it led to you helping make these solutions.
I think there's a lot of crossover. I mean, in military applications, when you're sending systems out in the field, they got to work all the time. They got to work every time. Yeah. But I think what you find in industrial applications is the cycle times and the up times for the vehicles, it's almost continuous. So you look in logistics yards or ports, they're running these vehicles 24 hours a day, 7 days a week, 365 days a year. Military vehicles, there's a lot of uptime, a lot of downtime. So what we find is being in applications where you're really running, continuous operations, that requires a certain level of reliability that, I'd say, the military, you have down cycles and maintenance cycles. And vehicles typically, unless it's a combat environment, aren't running 24/7, 365. Yeah. And so it really exposes our autonomy and our system to a huge number of scenarios, a huge number of learnings and edge cases that, again, really helps us benefit and improve our entire autonomy capability.
So some guy at the motor pool's like, you mean to tell me we can run these things continuously?
And that's the idea, is really, when you have humans having to run, especially in the military, running continuous operations, putting a 18 to 22-year-old behind the wheel in a combat environment, it's very stressful. There's fatigue. A lot of injuries and deaths happen from rollovers in the military. So we see the autonomy applications really stepping in there, but then be able to use that same technology and really increasing the throughput and reliability and resiliency of industrial applications. We see it's perfect fit.
Yeah, and looking back towards the commercial thing, big plans here. We've got it. What are you looking at as your outlook for 2025? And as you're doing this release and talking about it, kind of what's on your radar? What's top of mind, or what do you want folks to know about?
Yeah, look, I think we're taking a very deliberate approach with our partners. We believe very heavily in strong partnerships that are based on trust, based on mutual understanding of safety and quality. And so we're really diving in with Kalmar. They've been excellent partners and really doing it right to make sure that when we launch and we get this out into full operation with our customers and full rate production, that it's a product we can both stand behind and that really delivers the capability our customers need.
And these things will come off the factory fully equipped through the partnership. So it's a big OEM partnership, and it's one of the big challenges in the space is you got to find find a partner, especially in this. So looking forward. I really wanted to talk about the Claw too. I keep staring at it behind you. I'm like, so this is fascinating because, this is going to be one of the solutions that is the final leg of it. What were some of your thoughts when this was pitched? Because it feels like, I've talked to some people like, we're going to send a guy out and just manually tighten it by hand.
Yeah, I think we've looked at a number of different solutions. I think it comes down to one is safety. So having a human run out there, get behind the vehicle, manipulate the glad hands. It's a tedious activity. We look at price and reliability. So we want these things to work every time. It's got to work 100% of the time, not 90, not 95%. And we find that the solution from Electrans is a very robust, rugged solution. Much more we've seen, we've had our own yard arm manipulator, very expensive, got to get it just right. But then there's also issues where you got to connect both lines of the airlines, of the glad hands. You got to get both of them connected. And so that just increases the complexity. So we find that this solution with with Electrans fantastic partners, amazing product, really kind of bridges that gap of, the fully autonomous capability tied in with yard management systems, be able to tie in right into directly to the trailer autonomously, really provides that end-to-end autonomous solution.
With the yard management systems, I'm assuming eventually it can reach the point where you're communicating with the systems, you can self-diagnose. The vehicle understands it has an issue, it'll automatically pull itself in if it identifies a problem. Is that kind of what we're looking at ahead with these kind of capabilities?
That's right. I mean, we have a TerraLink solution. This is our internal command and control capability on how we task our robots, both in the field for military applications and then in yard applications. And this is, I think what's unique about TerraLink is that front end, that user interface, can tie into everything from, on the military side, what they call a ATAC system. Yeah. It is some of the soldiers wear on their vest. It's an interface they're familiar with. We can tie in the back end of that system and command TerraLink through that. We can tie into our customers whatever yard management system that they find they're most comfortable with. We can really connect to any really front end. We have our own front end as well, but that command and control capability and being able to seamlessly integrate into those operations, doesn't matter if you've automated inside the warehouse or even you've done over-the-road trucking, you right now have a very manual process in the interim. So having that connected, distributed yard management solution that ties into TerraLink and ties into the autonomy provides that full visibility, diagnostics, status of the robot, and everything else. So
that's perfect. Well, I really appreciate your time as well. Folks want to learn about Forterra or check out what you're working on. What's the best way to find out?
Yeah, you can go to our website. You can come check us out at trade shows, or we're out in Clarksburg, Maryland. Give us a call. We're happy to show you what we're doing. So
perfect. Really appreciate your time. That's gonna be a wrap for this segment. But don't worry, folks. We have a lot more stuff coming up. I'm at Manifest. There's trucks here. We're talking tech. See you soon.